doing SI for this lab, for this class, I found very helpful Dr. Vadi's Using Vivato with the Basis 3 Board Guide. And you find that here in the lab resources folder on the website. And so if you go to that, and then the Basis 3 manual, y'all saw me looking at that to look up where things were on the board. But this guide here, when I was first programming, I always had it next to me to look up to remind me how to do the different steps on getting started with things. So it has everything on how to get started, on how to put the how to put stuff in, how you're going to write stuff. So all of this it's all right there, and it's telling you exactly what you need to do. But included in this is this section 4 on functional testing. So what this is for is how can you test what you've been writing at home before you get into lab if you don't have the basis board. And that's what a test bench can be used for. You can't test everything, but you can test a lot of things. And what you can test is you can say, I want to send you different possible values of the variables, and I want you to display certain things for me based on what I send you. And so we're going to go through the test bench that he has here and then see how you would change that to match what you are doing for your lab. So the first thing is the time scale. You're going to leave that alone. The second thing is a new module name, so you will call it TB underscore whatever. You can call it whatever you want. You will want to follow the steps here for creating. You want to make a simulation source. So when I did this in Verilog sources, my test bench, which I just called TestBench, very creative name. I'm very good with creative names. I called it TestBench. You want to make sure it's under simulation sources. And then when you actually go to run it, when you get to that step, you do want to make sure that you follow these steps right here that'll tell you how to run it. So you'll do that. Okay, but here's the code that you're going to put in. So anything with the 2 slashes is a comment. That's just giving you information about it. So I never had to change the simulation time. So he has this note here saying if you need to, if you don't see test bench complete to change this, I've never had to use that. But so you'll have module test bench main. Then you'll define as reg anything that's an input in your main module. So you'll look at your main module, which I called mine display. And so anything that's an input, you're going to define that as a reg. So right here, see I've got reg10xy, here display, so here it was input 10xy, here it's reg10xy. Okay, then anything that's an output, you're going to declare as a wire. So here I have in my main, I have AN and segment are outputs, and in my test bench they are wires. So you do that. Then you are going to instantiate the unit under test. That's what UUT stands for. And this name right here, main, that needs to match the name of your module. So on mine, for instance, my module, I called it display underscore RR. And so I have display underscore RR UUT. And then I have my inputs and outputs right here. So you'll have whatever the name of your main module is, UUT, and your inputs and outputs right here. Now, if you put you have different notation you can use. So I put them in the same order as they are in mine, and then it works fine. If you don't want to worry about if they're in the same order or not, you can say how you're going to map them by using this kind of dot notation. So here, if instead of putting capital A, capital B, capital C, so forth, if I put dot A, open parentheses A, dot C, open parentheses C, then that would mean that in my test bench, that they wouldn't have to be in the same order, that whatever I had associated with main, so in my main I have the variable A, and then so in this particular example, let me grab this. Okay, so this is the test bench. In my main actual Verilog code, then at the beginning it would look like this, and this would mean that A corresponded to A, B corresponded to B, C corresponded to C, D corresponded to D, and E corresponded to E. So those would be the variables that I would use. If I didn't want to worry about them being in the right order, then I could instead use that dot notation. So go back. Right. Okay. So now you'll have your initialization. So you'll have your initial part, so it'll say initial, and you'll have begin, and then the $ display, that just displays something on the computer screen. So when you run it, it'll show TestBench start. And then display, that's just a display, that's just a print statement. It's going to say what the values of A, B, and C are. Well, this is just a display. I mean, it's just text. It's just going to print exactly this on the screen. And then our other initialization is that this is initializing A, B, and C together to be 0. So it's making A, B, C equal to the 0, 0, 0. So A, B, and C are all 0. It's treating it as a 3-bit number, the A and B together. So this is just initialization, getting things started. Then you'll have an always block, and you'll have your always block, you'll have a begin and an end. This pound 10 is just saying wait for 10 seconds, or 10 nanoseconds. You can play around with that to see what it looks like. And then you have a $ and display. And then this tells you, I know a number of computer languages, and I can't remember. I don't think C++ uses this kind of formatting. What this is saying is that you are going to display some variable values. You are displaying the values of A. I take it back. This is not a 3-bit binary number. These are decimal values, and they're making them all 0. So you're going to display the values of A, B, C, D, and E. And then in quotation marks here, I have the %. The % says, go get the value of the next variable in the list after the quotation marks and put that value there. And the D is saying it's a decimal value. Display it in decimal form. So the first thing it's going to display is the value of A. The second thing is the value of B, the third C, the fourth D, and the third E. And this vertical line right there, that's just being displayed as is. That's just text that's displaying right off. Then I have this if statement. Nope, okay, I take it back. These are, in fact, binary numbers. I lied. It's just displaying their decimal values. So it's saying if ABC equals the binary number 111, then you're done. So it's counting through all our different values for A, B, and C. So it's starting with 0, 0, 0, then 0, 0, 1, then 0, 1, 0, and then 0, 1, 1, and so forth. So if we've gotten all the way up to 1, 1, 1 from 0, 0, 0, it'll display that it's done. And this right here, this command is saying you're finished, you're done, so you'd put that in there. Else, it's saying increment ABC by 1, so go up by 1, and then it'll end the module. So let's see how that works in practice. So I'm going to go over to my Verilog, and I see that, let me get, okay, so here I have my test bench. And I can't see it. All right, so I have my inputs are reg, my outputs are wires. I gave it the name of my module, UUT. I did not use the dot notation. I actually used the same variables. That's very bad programming practice. See, I used exactly the same variables. So I wasn't mapping lowercase x or anything like that because I'm lazy, and that's bad programming practice. Okay, and then I have my initialization, and I'm just saying this is what I want to see the values. I want to run through all my possible values of x and y that would correspond to my different switch settings and see what values of AN and segment I get. And then I have my always block. I have a little delay here. I'm telling it that I want to display the binary values, not the decimal values like in our sample, but I want to display the binary values of x, y, and AN and seg. So it's going to give them to me in binary format. I could do them as decimal. If I preferred to see them as a decimal number or a hexadecimal number, I could do that as well. And then I'm telling it that if I get through all 16 possibilities for x and y, that I'm done. Else, I want to add one to x and y. And now I will show you how this works. So first, I want to look at what we had here. It says right click on your test module under simulation sources and make sure that set as top is grayed out, otherwise click it. So So I right clicked on it, set as top is grayed out. Good. Okay, so that's what I want. Okay, then I will go to under simulation in the flow navigator, click run behavior simulation. So run simulation, run behavior simulation, blah, 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 blah. Yes. Because it told me that error because I ran it earlier to make sure it worked. Save project, no, because I don't know what changes I might have made. It's going to be a minute because I don't know why Vivado is as slow as it is. I don't know what all it's doing. It must be doing some fancy things. Okay, so then what it shows me down here at the bottom, I have, if I scroll up, maybe it's, so it's saying TestBench start. It has that little display that I had there, and if you look on the left-hand side, it is scrolling. It is going through the different values of x and y, and so with all the possible values of x and y, and then it's showing for those values of x and y, what are the values of an and seg. So that's not telling me exactly what the basis board is going to do, but it'll at least tell me if my logic is working correctly, because I may have not gotten correct this one right here would be everything on. I don't remember, was there something with everything on? I don't remember that there's something with everything on, but this is saying that everything would be on. I may not have done that correctly, but if I thought I did, this is at least telling me that when I have these values for x and y, that I have whichever display this corresponds to is set, and this is what I would get out of that display.
I was just wondering, would you suggest we do it in binary versus decimal for the
I would. And the reason
Okay.
I would is because that's how we're thinking of it, because we're thinking of these things as individual segments, as being on and off, and not as a number. So,
Okay.
yeah, so I would, yes.
All right.
Okay, other questions?
I'm not sure if you already went over this or not, or if I just missed it, but under the test bench for display, where it's %B,
Yes.
and then the other one is %D,
Yes.
is that binary and then the decimal?
That is binary and decimal.
Okay.
And yes, I did go over it, but I'm happy to go over it again because I talk fast. So what this is doing, and I think I paused when I went over it because I was trying to remember how C++ does things, and I don't think C++ does things this way. MATLAB does. So when are y'all doing what's the class? The class that you do MATLAB in.
The electronics class?
No, well, you might do it in there too. I actually, I don't think you didn't do an electronic. I never took it, so that's why I don't know. But anyway, MATLAB does do it like this. So I want to display the values of variables. So in my display line right here, I want to display the values of x, y, an, and seg, but I can't put those inside the quotation marks. Inside the quotation marks, I have little placeholders for them. The % symbol means I want you to go get the value of the next variable in the list after the quotation marks, and the letter tells you what format to use. So here, when it displays, this first one is going to be the value of x, the second one is the value of y, the third one's the value of an, and the fourth one is the value of seg. And if I changed these to decimal, it would have put them in decimal format. If I changed the b's to d's, it would have put them in decimal format instead of binary. If I changed it to h, it would give them as hexadecimal.
Okay, thank you.
You're welcome. Other questions? All right, perfect. So my timing is